Hello everyone, Alex here, and today I'll be taking a look at the new Solidoodle Press desktop 3D printer. This is the box that arrived at my door. Let's see what we have. USB cable, power cord, tools including a scraper, tweezers, and a brush, a quick start guide, the DC transformer for the power cord, and of course the printer itself, which was a bit awkward to remove from the box. Also included is the manual. Once you have the printer out of the box, you'll need to remove the foam block around the build platform. Opening the outer lid, you'll find that the Solidoodle Press also comes with a 1-pound spool of ABS filament, which is very nice, and you'll want to remove that because underneath the inner lid you'll find one more block of styrofoam, and this one is a little tight, but with some finesse you can remove it just fine. One of the first things you'll need to do is load the filament. To do this, lift the outer lid and place the spool into the holder. Next, take the end of the filament and push it through the center peg. Once you've done this, you'll need to open the inner lid and insert the filament into the top of the print head, making sure to lift the small black lever on the side of the print head as you insert the filament. Now we're ready to connect the press to our computer. I had a bit of trouble with my computer not recognizing the press, but I was able to fix it by going to Devices and Printers and troubleshooting the press. After that, I had no further connectivity issues. Once we've selected our printer in SoliPrint, it's time to test the extruder. After heating the printer, you can go to Tools, Extrude, and select a length of filament to extrude from the nozzle. If everything is set up correctly, you should eventually see something like this. Now that the press is up and running, it's time to calibrate the Z-axis. The press has a very cool feature that eliminates the need to level the build plate. It has a small button on the print head which allows it to check the height of the build plate at 9 different points, and then it uses that information to raise or lower the build plate depending on where the print head is. In short, it compensates for the uneven build plate. However, in order for this to work, you need to tell the printer how far the button is from the nozzle, and that's what the Z-offset calibration is for. Solidoodle has a video that explains the procedure, so I'll link to that video in the description. Basically, the press prints 11 lines using different Z-offsets, and then it asks you to pick the best one. Using SoliPrint 1.1.4, I've been able to calibrate my printer just fine. I will say one thing, however. When it asks if your Z-probe is down, make sure you've pushed it down, otherwise your printer will do this. The very first thing I printed was this hollow pyramid, and I'll put a link to it in the description. I loaded it into SoliPrint, heated the printer, and let it go. The only change I had made to the printer itself was to calibrate the Z-offset. Everything else about the printer was out of the box, including the sticky coating on the build plate. The first print didn't stick to the build plate, so I tried again with a scaled down pyramid, and this one printed much better with only minor warping. I went and printed a few more things, but by this point I needed to improve my build plate adhesion. There are many ways to get your parts to stick to the build plate, including hairspray, ABS slurry, and various kinds of tape. However, I've found that glue sticks are much simpler and very effective. As you can see, I use Elmer's washable glue sticks, and I usually apply 2 to 3 layers in a cross-hatched pattern. Once the build plate is covered, just pop it in the printer and you're ready to go. You will need to replace the glue every few prints, but the good thing about glue sticks is that the glue washes right off. Other methods like hairspray and ABS slurry are a little more difficult to remove. Glue sticks may be simple, but the results speak for themselves. One of the frustrating things about the press is the fact that it doesn't automatically lower the build plate after each print, at least not enough to easily remove the part. To lower the build plate, you need to manually enter G-code through Soliprint, which isn't really that bad. To manually enter G-code, go to Tools, Printer Config, and look for the text field near the bottom with the title G-code. This is where you can give individual commands to the printer. The command to lower the build plate is G1 space Z, followed by the desired distance between the build plate and the extruder. Choosing a value of 100 will bring the build plate about halfway down. Now your part can be easily removed. To see a full list of G-code commands, click the link in the video description. That's it for this first look at the Solidoodle Press. Stay tuned for the next video where I'll discuss some of the problems I've encountered and the modifications I've made. Thanks for watching.